people ask me about the safety interlock on this governor. Well, it doesn't have one. It's not like the Pickering governor on the ONS engine. That explained, I think it was video 3.5, how that governor worked and had a safety device that shut the engine down, dropped the valve in the governor if the valve failed. Well, this is an old gravity governor. It predates the Pickering platform. And it has this lever over here, which a chain or rope can be hooked to it. And if you pull this lever, it will force the valve down against the spring and slow the engine down, at least if something is going wrong. But it doesn't have any way to shut it off. So the question is, what would happen if the governor belt broke or came up? Well, I don't know. Let's find out. I have I don't know if I get the camera aimed so you can see it, but there is a quarter turn shutoff up here in the main steam line. I've got a pulley hook to it. It is ring here. And this is the emergency shutdown. If the engine starts to run away. But you have a lot of compressed steam down through here and in the condenser that after you shut the valve, it's still expanded, so it's not going to shut off instantly. So, let's just see. It takes off pretty fast. And that's why you want to keep your governor belt in really good shape. Now that did not exceed, I'm sure, 200 RPM, which is probably what the rated speed of this engine was. But with 60 pounds of pressure on the boiler, you can imagine what that would have been like with 175 pounds. Reset the valve. Nope, wrong side. Back to another issue of old steam-powered machine shop. So we got the boiler fired up this morning on coal. We've got a few clips I'm going to show you that I either forgot about or didn't have room for in the last video. And we're back to work on the Morris Machine Work engine. It's been a while. We've been interrupted with other things, but back to work on the connecting rod. And I'm making some rod brasses for the rod bearing. And I'll show you about that in a second. Thanks a lot for all your comments and likes. And we'll get right to things. So the first thing is I want to show you what I actually did to quiet down the clatter that was in this engine. And so we'll do that right now. Well, you got basically two places that knocks and noises can be coming from. Either the valve mechanism, which goes back to the eccentric, or the piston rod crankshaft system that runs the crank. The rod noise and main bearing noise will be more of a heavy pounding, where the valve noise obviously would be a little lighter clicking kind of a thing. Well, this was actually doing both, and I could feel it in the eccentric, but yet the eccentric wasn't loose. I shimmed it up a couple times and I was sure I was okay there. There was nothing here that was going on. So last resort, I took the steam chest back off again. And if you remember in that video when I showed you what was going on with the valve in here, this rod here goes through the slide valve, and it has a nut and a jam nut on each side so that you can adjust it, adjust the lead the same on each side, each top dead center. And I said that you need to leave the slide valve a little loose in there so that it can move around. Well, you don't want to leave it too loose. Well, I tightened it up a little bit until it took all the slack out of that, but yet I could still push and pull that slide valve back against the ports, and it had almost no clearance this way. I put it back together again, and it's as quiet as a mouse. So you learn something. This valve down here is the blowdown valve. It's actually a drain valve on the bottom of the boiler down here, where this boiler shell is double thickness right here. The firebox is inside. It's the lowest point on the boiler, and it actually drains the water out of the boiler, or you can use it to do what they call a blowdown, which you should do at least once a day, to blow impurities and any kind of garbage that is being concentrated in the water out. That pipe runs out the wall. When I set up this shop, my intention was to try to demonstrate it, of course, but also to find out what it would be like to use steam power on a daily basis. And there's some interesting little quirks that you find out about. One is if you're using the boiler and it gets late in the afternoon and you're almost done, and you've let the fire go down and the pressure is down to finish up the job, and then you're stuck with hardly any steam at all and only a couple of inches of water in the boiler. Overnight, of course, that's going to contract the water will when it cools off, so you'll only have maybe an inch of water in the glass. And you really should have a full glass of water for startup. So you have to put water in the boiler from some external source, and it's kind of a pain in the neck. Well, I found out that if you just leave the water valve on the injector and the injector valve open, when the steam goes down and the boiler cools off, it creates a vacuum. And it's quite a significant vacuum in this thing. And if you leave the water on, it will actually overnight pull almost a whole barrel of water into the boiler. And when you come out in the morning, it's right up where it should be. It's kind of amazing. And early steam engines, really early, like back with James Watt and those guys, when they were making pumping engines over in England, they were trying to pump their mines, the coal mines out. The first engines that they invented actually didn't work on steam pressure. It worked on the vacuum created when the steam cooled and condensed. They didn't have anything to safely build any pressure in. It was just a big cast iron ball, hollow, that they put water in and built a big fire underneath it. And they would pump steam into a cylinder and then shut it off, and it would condense and create a vacuum, and the suction would pull the piston up. And that's where they got their power from. And then they would exhaust it and blow more steam in there, and after the weight of it went back down again, and it would suck it up for another stroke. So the vacuum created when steam condenses back into water is pretty amazing. Well, we're back to work on the Morris engine. This is the connecting rod. The upper end of the rod, I've already cut some off the mating surfaces and keyed them up tight with a wedge here, and bored this to a really nice fit with the wrist bolt that we made. And in the future, it could still be taken up by taking a little off the mating surfaces here and running this wedge in a little tighter. The bottom was just too far gone to do that. These are the bearing halves, and there's a wedge here that will, if you loosen this set screw and drive this wedge in a little, it'll tighten it up. But as you can see, it's way past anything that's usable. I could have probably relined this with something, but I decided to make two new bearing halves. They call them brasses. And the way I'm going to go about this is, I have the stock cut and set up in the milling machine. I'm going to mill these out to rough size. Well, there goes the release valve on the boiler, so we got plenty of steam. And then cut these screws. Do all this machine work here and fit them back into the rod. And then key it up tight with the key and bore the hole out clamped tight in the rod. Leave about maybe 2/1000 clearance against the crankshaft pin. So that's the plan. You shut the draft down on the boiler and quiet that down.
This is the stock that I bought to build these brasses out of, and I cut 2 pieces here and I ganged them up, and I'm going to machine the mating surface of the 2 in one pass on the 1885 Brown and Sharp here with a face mill. It's actually so quiet. What you're hearing is the gears in this transmission. I think that'll be satisfactory. Now we got a little less than 2 1/4, so we got quite a ways to go. Might be able to speed up the speed a little. This right here goes to show you what you can find on eBay. This is a factory engine plate for Morris Machine Works steam engine. New old stock, never been on an engine. Someone had it on eBay, claimed that they found or stole this out of the ruins of the old plant before it got torn down. So I was very happy to get this. Okay, we're set up to cut this area out here. It's 2 inches wide. The groove width is 1 3/8. That leaves 5/16 flange on each side. The most critical dimension is 1 3/8 here. Well, there's the first part. Got both brasses in here doing the side.
on this. Had to round this off for clearance down in here. And these are, the old ones were numbered and I numbered these the same way. This has got a 2 stamped in it and 2 here and 2 up here. See where it's been taken up for wear through the years. Oh, it's Saturday morning. It was 9 degrees here this morning. Done a little more thinking about this, and these 2 bearing halves will fit in this strap, which is the lower part of the connecting rod, very tightly, and line up with it, with the surfaces. And the key through these slots here, this wedge, which is an adjustment wedge, if I drive that up tight, everything stays in line really well, so I don't have to get the rest of the connecting rod involved in this deal. So I found the center of the parting line here and center punched it, and now I'm going to line it up, indicate it in, with an ancient wiggling tool, which is just a pointer. There's a little leaf spring here so you can run it up and have some tension against the hole. And when you spin this around, because this is a lot longer than it is on that side of the pivot, it inscribes a circle here that's exaggerated. And then if you pull the center up, fairly close, you can see how far off it is. Too much.
pretty close right there. Okay.
Trying to run this morning, so I like to warm the cylinder up a little bit.
Glass can be a kind of a pain in the neck because it wants to hog in and stick. And you can help that a lot by dubbing off the angle on the rake of the drill. But I don't want to mess up this drill just for this one brass boring job. So I'm taking it real easy coming through here. Okay, that's enough of that. Get out the boring bar. This is a blacksmith made boring bar. I believe came out of the Lehigh Valley Locomotive Shop in Sayre, Pennsylvania. So there's no telling how old it is. I ground it up. We're gonna try it and see how it does. our earlier videos, you remember the crank pin on the crankshaft of the Morris engine originally was 2 inches in diameter, and when you got through rebuilding it, it was 1/970. So that's the magic number here, 1 inch 970 plus about 2,000 for lubrication clearance. Trying to come up with a good feed rate for this. Not looking for any kind of a surface finish at all. Just want to get the material out of there. I reground the tool bit so that it's more of a radius on the front edge. And I've been experimenting, taking light cuts and small feeds, seeing what kind of surface finish I can get, and just kind of playing with it as I'm coming up on the final size. I think they're going to be good. Right now, I'm at 1940. I'm going to go through that. I touched it up one last time for the last 30. I was really surprised how well this thing actually did. I mean, this has got no carbon in it practically. It's just a piece of wrought iron that had some kind of case hardened on it, maybe. Maybe not. It works good, but you gotta, the edge doesn't last very long. I have a tool here that I ground with a radius in it. And I've got it set up this way because it's got to be straight with no rake. Tool holders. Most of these old tool holders. Like this are got an angle for the tool to give it the rake built into it. You need one that's straight like that. I don't have one. So I got it set up in two places. Not going to take much.
thing is, it has to be relieved here about 80 thousandths deep, and a radius put in here, and a fillet. Not really critical what the radius is. I've got a round nose length tool bit in it, and I'm going to use that. Oh, there it is installed, D-bird, notch cut in here for a little set screw clearance. Pretty much on dimension here. I'm gonna paint the body of it, and next video we'll put it in the engine and see how it fits. Thanks a lot.